in the previous video we have done the WDM through the Scientech 250 kit. In this episode we will do the software demonstration of the wavelength division multiplexer. So here we are using the software that is optisystem. It is basically used for the optical fiber communication. First of all, we have generated the pseudo random bit sequence generator. Why we have used the pseudo random bit sequence generator? So that we can generate the input digital pulses. Okay, so this is used for generating the digital pulses. Now next one is that the NRZ pulse generator. What is the purpose of NRZ pulse generator? It basically provides you or gives you a hint that which format you want to use it, whether it's an NRZ pulse generator format or the RZ pulse generator format or what. Next we use the Mach Zehnder modulator. We already know for transmitting the signal to the higher distances we will use the Mach Zehnder modulator, and we will provide the carrier signal, that is a continuous wave laser. So right now we are dealing with the WDM. So right now we are demonstrating the 2-channel wavelength using the WDM. So that's why we are using the 2 light sources. So this one is at 193.1 terahertz. Just double click on this and then assign the frequencies, that is 193 terahertz, like this. If you want to observe it at nanometer, then you can observe it at nanometer, and if you want to change its unit to terahertz, then its buttons are available here. Next light source is available at 193.2 terahertz. So this is what the transmitter side. Then obviously we have to use a WDM multiplexer. Now WDM multiplexer, we have to provide the frequency to the channel. So just double click on WDM mux, then go to the channels, and then 193.1 and then 193.2. Why we are setting 193.1 and 193.2? Because initially we have taken the 2 light sources having the wavelength of 193.1 terahertz and 193.2 terahertz. Next, this is what the transmitter side is completed. Then it's turn to come the channel side. So this is what the channel section. First of all transmitter, then channel, and then receiving part. So this is what the channel is nothing but the optical fiber, because we are transmitting the signal to the optical fiber. Okay, so this is what the optical fiber. Just double click on that and then choose the reference wavelength, either 193.1 if you want to observe it, refer to 193.1 terahertz, and if you want to observe your result according to the reference wavelength 193.2, then set it at 193.2 terahertz. Then assign some length of the optical fiber cable. Right now we are starting with 5 kilometer. Then this is the receiving side. Again we have used the WDM demux, assign the channel value same as 193.1 and 193.2 terahertz. Then this is the pin photodiode for detecting the signal. This is the BR analyzer for analyzing the quality factor and the bit error rate pattern. This is what the optical spectrum analyzer and WDM analyzer also we have used right now beside the WDM multiplexer, so that we can observe the 2 signal in the frequency domain also. And in WDM multiplexer we will see the OSNR value, the SNR value, the power levels, right? These type of things we can easily observe through the WDM analyzer. So this is the simple circuit diagram of the WDM, study of WDM. Now we will click on this run button, this triangular shape. So project is already run. Then click on the bit error rate. So this is what the bit error rate. If you want to see only its quality factor, so just uncheck this. This is what the quality factor. We are getting the maximum quality factor as 6.41522, and we are getting the bit error rate pattern like this. See, your eye opening should be wider. If the eye opening is wider, that means the noise level in your circuit or in your network is less. Right now there are some noisy, as you can see the noisy spikes here in the eye diagram. Similarly, we will observe the bit error rate pattern 2 of the second source. This is like that, 6.40408. Now we will observe the optical spectrum analyzer, the 2 signal in the frequency domain. Just click on the zoom button so that you can see the 2 signals at 193.1 terahertz and 193.2 terahertz, like this. WDM analyzer, what WDM analyzer will do? This will give the noise power, signal power, SNR, noise power, anti-logarithm, and then OSNR. So this is what the different demonstration of the different things like signal power, noise power, OSNR through the use of WDM analyzer. We can also use the optical power meter here also. Now suppose I want to minimize this noise level. So for that there is one component in the optisystem. We will use it, optical amplifier. So just choose that optical amplifier and then connect it beside the cable like this. Join it. Now we just connect the optical amplifier between the fiber cable and WDM demugs. Then we will run the project. So see, there is a less spikes, bit error rate pattern. What you observe, the clean bit error rate pattern, and obviously the quality factor also increases from 6.4 to 6.50567. Previously what we get the bit error rate pattern, some noisy pattern, but here this is more clear. Again we will check the second source. We get 6.407 in the previous work, and right now we are getting 6.46194. So this is what the simple demonstration of the WDM.